I just want to give you a background of generative AI. It's largely focused on ChatGPT. I'll give you some examples of what ChatGPT can do. I'll show you some just astonishing examples of its performance. So take a look on college entrance exam. Talk a little bit, we don't really have enough time to go into some of its limitations. But then I wanted to add a second section, which is, of course, much more relevant to this conference. And that is basically how do we create and embed new curricula involving generative AI. Something that kind of intrigued me is, I'll go into some details, and ChatGPT is serving a Ph.D. thesis about it right now, and I think there's some pretty astonishing results there. And then, recently the question is, can we generate new research results? Not publications, but truly novel research results using generative AI. So we're waiting on that. By the way, you may have seen it, speaking of science and AI, that both Nobel Prizes that were announced this week in physics and chemistry involve contributions from artificial intelligence. Physics, really more computer science, but also in the social structure prediction. And then we have some discussion about issues at the end. So let me just start at the beginning. So really going back to what Google was. Google's been around now for, 26 years. This is a literally screenshot from 1998. Back then it had 25 million page index, soon to be much bigger. They got that right. This is a slide from a year ago. It's clearly approaching a trillion pages index. So if you think back to why was it that Google became the #1 search engine, at the time it was because of something called the Google PageRank algorithm, which is a way of assigning authority to pages that were returned by a query. And basically what this algorithm does, in fact people in computer science classes sort of programmed it, is that it looks at the link structure, that is the number of links that come into a web page, and assigns an authority based on the number of links, but most importantly what the authority is of the pages that link to it. So this can be posed as a massive linear algebra problem, although Google, I should say, has continued to modify this in many ways over the years. I just mention it here because it continues to be a very useful way of filtering this information. So if you ask Google, tell me about the efficacy of COVID vaccines, for that reason, they rank much more likely to be taken to the CDC and FDA sites than, shall I say, some site by Beijing. So one of the reasons to mention this is it's less clear, certainly to me, basically how ChatGPT deals with misinformation and content that may be unreliable. So now we fast forward to November 2022. It's hard to believe it's almost 2 years now that ChatGPT has been an integral part of our conversation, and we'll go into more detail there. So let me just show a quick example from Google, and we'll do the same thing with generative AI, ChatGPT. So here's a relevant question: what is AI and how does it work in Google? And as everybody here knows, Google returns a snippet verbatim of text, and more, I think, of course, another search engine does that as well. Now, what's important is that just several months ago, Google introduced what they call AI overviews. And you may have seen that if you, more and more now, if you ask Google a query, it will come back with something that's quite clearly denoted as having been generated by AI. And it's basically a summary of the text that is found along with relevant links. And this, of course, is, while I'm not talking specifically about Google, as you know, they have an AI model that runs AI overviews. It was called, and momentarily what they call it now, but again, we're talking about ChatGPT here. So here's an example of the same query in ChatGPT. You able to read the text. Well, what is AI and how does it work? And what you get, of course, as anybody here who's used ChatGPT knows, you get a very well-written piece of text that defines what AI is, its types of AI, and how does AI work, and of course I truncated that here. And as you know, this is, in general, is novel text. That is, if you were to take a subset of this text and paste it back into Google, you're unlikely to find an exact match because, of course, it's been generated by a massive deep learning algorithm. So just some quick comments on ChatGPT. Sorry, some of this is pretty general for this audience, for people who are not versed in these things as this audience. So as you know, you can get ChatGPT, OpenAI, of course, everybody knows OpenAI these days for any number of reasons. It develops ChatGPT. So examples that I'm using, showing here are from the most recent version of ChatGPT. It's called 4.0. And that was just released last month, September 12th. And by the way, this is a small point. It's well worth it if you're using ChatGPT to get the subscription to ChatGPT Plus. It's $20 a month. It not only gives you access to the most recent versions, it gives you access to the most recent versions, but also gives you much faster turnaround. But if you don't subscribe to it, you'll find it very stuff. And I executes promptly. And the other thing is results from ChatGPT change dramatically, sometimes session to session, particularly because it knows what you said before to ChatGPT. So the results I show here are difficult to replicate even for me, by the way, because as it learns more about me, I get different responses. So let's just talk a little bit sort of about the academic progression, if you like, of generative AI. So we started the talk with machine learning, which is sort of the fundamental science under the covers of AI. It's been around for decades now. Very simply stated, involves the construction analysis of algorithms that learn from data. So machine learning, you have basically an objective that is a measure of the extent to which the algorithm fulfills an objective. You have an amount of data, and you have what's called in the parlance a learning curve, which basically shows how, as the model is trained against more data, it improves the performance according to that metric. And examples of machine learning are text classification. We were doing at IBM like 15 years ago, was trying to classify a piece of text as it's positive or negative sentence. Image classification, being able to detect skin cancer, melanoma, via algorithm, but now at the level, so nothing to do with generative AI, other levels of the best human observers, and something called deep learning, which is really the underpinnings of ChatGPT and so much of everything else that's in the discussion. Deep learning, very simply stated, starting with what's called an artificial neural network, which is recognized for the development of that in the Nobel Prize for Physics, and basically is a computational instantiation, if you like, kind of the simple model of how the human brain operates. These models are massive now, trillions of parameters. We can talk about that in more detail later. So, moving on to AI. AI is the theory and development of computer systems able to form tasks that normally require human intelligence. So that's a high-level definition that's been around for quite a while. And interesting enough, I actually gave a talk, maybe not in this room, but at Westcon like 7 years ago on AI, and this really cool slide that basically shows sort of all of the disciplines that sort of fed into AI at the time: machine learning, natural processing, natural language processing, optimization. Optimization is a key way of training these massive neural networks, and something called reinforcement learning, which is an important part of AI now. It allows a learning algorithm to improve its performance against some objective by basically repeating the process many times. And that brings us to generative AI, which of course are just AI systems that are now, instead of classifying documents or classifying images, are actually generating new content, text, images, audio, video, and computer code. I'll show some examples of that in a moment. As I said, that's ChatGPT, several other as well, and this now includes, as its academic underpinnings, massive deep learning. So here's an example of text generation. So I asked it to generate a 1,000-word essay on critical race theory, but I did it from two perspectives. One from the conservative viewpoint and another from the liberal viewpoint. So, like a lot of us, when you ask for 1,000 words, ChatGPT is just like lots of us humans, gives you more than 1,000 words, many more. So it seems to do everything well except do the word count. So this is just a subset of what it gave. Now, critical race theory, because there's a lot of discussion on both sides. If you're not familiar, critical race theory is this It's a theory that's been around since literally 1980 that suggests that racism is not the result of individual bias or prejudice, but in fact is systemic. That is, it's sort of embedded or baked into our institutions, most notably our judicial legal system, which is why, by the way, every single major law school in this country still teaches classes on critical race theory. My only point here, we won't go through this text, is that there's been a lot of discussion early on, like a year or so ago, that ChatGPT is biased. And that's a very long discussion that has some technical ramifications we won't go into. But the point is, and this is also the beauty getting back to its use in education, is that I can force it, as I've shown here, to behave like a conservative and those viewpoint. Just one observation, frankly, I tend to side on the liberal perspective here. I would suggest that the conservative argument here, when I look at it, closely seems to be better posed, better argued than the liberal perspective. So that's an example of generating text. I don't know if you know that, I'm sure. Of course, it's generative AI because it also generates additional text. So OpenAI has a system called DALL-E. This was DALL-E 2 that came online actually before ChatGPT. DALL-E 2 is named after Salvador Dali, who's a Spanish surrealist artist, of course, and it generates images. And they went to DALL-E 3, and now DALL-E 3 is incorporated directly into ChatGPT, so I can do this from ChatGPT. So here's a simple example. You'll see in a moment why I have to choose this particular font. So what I can do is I can say a 16th century English playwright using a laptop in a contemporary setting, and there's the laptop, there's the playwright presumably, and there's the contemporary setting. So why did I pick that? Well, I used to, like 6 months ago, I used this example, William Shakespeare using a laptop in a modern setting, and sure enough, I got this image on the left. This was January 2024. So when I was refreshing these slides, just now, I thought, yeah, I go back because everything changes, and sure enough, it changes. It will no longer give me a picture of William Shakespeare. In fact, I get this nice little legalese that says I wasn't able to generate the image as requested due to content policy guidelines if you weren't even provide a new description and so forth. So this is what it gives me as of now. So of course, what is going on under the covers is ChatGPT is working nervous, or I should say OpenAI is very nervous about generating content about any public figure, believe it or not, including, 16th century, 15th century Elizabethan era playwrights. Okay, so needless to say, if you ask it to generate some image of Donald Trump, it will, or even text now, it will probably decline simply because I think there's this overriding concern about generating content that is potential misinformation and potentially persuasive with upcoming elections and so forth. So is this a bug or a feature? I'll let people decide, but it kind of surprises me that it's so broadly applied now within OpenAI tools. So here's a nice example for anybody who does computer science here. As people know, ChatGPT is an amazingly capable programmer. So here's a simple example. Write Python code that computes the area of the circle given a radius as an input variable. So indeed, it gives me a very simple and correct Python code. And what's also interesting, this has just happened in the last year or so, it also gives me a nice little explanation. So it takes the radius as an input, calculates an area using a formula, and so forth. So, but here's the scary part, as I say. Anybody ever heard of ALGO, computing language ALGO? One person. You look too young to have known ALGO. When I was an undergrad at Stanford, my first programming language was an ALGO. Why? Because computer scientists were on a mission to find any language that actually obeyed, important computer science constructs that wasn't called Fortran. Okay. So, and my Ph.D. thesis was completely, it was in computational physics, was completely written in Fortran. So, of course, remembering my love of ALGO and Fortran, I asked it to generate the same call in ALGO, ALGO and Fortran, and it generated me a piece of ALGO code, which I had no idea was correct. And by the way, I can't even find an ALGO compiler online to tell me if it's correct. But that, and of course, it gave me Fortran 77 as well. So you start to wonder, well, wait a minute, how is it that it has learned how to program languages that haven't been used now in decades? And the answer is, it's not just using a programming manual, it's still found examples out there. And as you probably know, there's been a lot of controversy. It's using code that's in GitHub. I've code repositories there. Everybody has code in GitHub, and it's now being used to teach programming tools, not just ChatGPT, but other systems to program. And of course, it is now becoming remarkably efficient at doing what are kind of mundane tasks and writing blocks of code that previously required skilled human programmers. So how good is it? Well, one example is that, if you interview at Google, they give you standard coding tests. And of course, people treated at Google, since ChatGPT is not their tool, but nevertheless, they fed their interview to ChatGPT, and it aced it to an extent that it could actually be hired on mentioning to Google, and the compensation of that position approaching $200,000 now, probably more. So that just gives you an example that ChatGPT is ready to go out and take jobs that humans are paid significant salaries to do. And here's just when I'm sort of finishing up the section here on sort of performance and just some amazing things you can do. And I'm sure people in this room will be kind of interested in this. This is actually quite dated. These are results that OpenAI published in March of 2023. And if you look closely along the x-axis there, you see a number of probably your personal favorites in terms of tests. The SAT, so-called the SAT Verbal, SAT Math, AP World History, LSAT, and so forth. These are rank ordered by the blue bars are GPT 3.5. GPT, by the way, stands for Generative Pre-trained Transformer. Generative because of generative AI, pre-trained because of the large model, and transformer because it transforms ability into an output. So that's what GPT is. So GPT 3.5 is in blue, and at this time a year ago, they had just introduced 4, which had made dramatic improvements in performance. So on the left-hand side is the percentile ranking of the output for this, the outcome of the results for each of these tests. And you can see that now a number of them are outperforming as of a year ago, with GPT-4 at above 80%. Now, my point of view, particularly because ChatGPT 4.0 is optimized to do deeper reasoning, that I think it would probably do better on these things. But for reasons I don't really understand, OpenAI, to my knowledge, has not updated these results. But again, they're pretty spectacular. Here's just a summary. So on the evidence-based reading and writing, it's called verbal, SAT, it does 710. On the math, it does 700, and those are order 90 percentile. Actually, gets better, not surprisingly, on verbal, and it's just it was the recent improvements that allowed it to do math, because we have various sort of processing of non-textual information that's required in order to do well on that exam. It's 88% on LSAT and basically 90% on a quad exam. So that's the first section here. What I'm only spending a fair amount of time talking about is hallucination, bias, and misinformation. I'm going to skip over that. But let me just make a comment about hallucination. If you like the textbook example, at least in my mind, is summer ago, there was an attorney, this was written up in the New York Times, an attorney was a little bit tired and running a little bit late on getting a brief to the court, so he said, no problem, he went to ChatGPT. ChatGPT gave a nice little brief, and with 6 references, previous court decisions, it turned out these court decisions were completely fraudulent. They were made up, they didn't exist, but they looked quite realistic, and in fact they were realistic enough for the attorney to submit it to the court. It was only the opposing attorneys, when they used real search tools that lawyers use, determined they don't agree. So what happened? This is hallucination, just made it up. So effectively, think of it this way, it was, it's kind of an obscure case of law. Details are important, but there wasn't a lot of case literature there. So basically, sort of think of it as an interpolator. So it went all the way down sort of into the lower end of its knowledge base, if you like. That's not the true representation. But basically, since it couldn't find enough, it just effectively kind of interpolated it, if you like, among the knowledge. Bias is a very long discussion. I would say that when I see in ChatGPT, I have a series of political assertions that I submit to it every month or two to see what the sort of bias du jour is, and it goes back and forth between being very rule of being non-committal, but it was non-committal right before saying, oh, I went to the Senate hearing a year ago, and he told the guy that OpenAI that and he's got some Washington yard to deal with on regulations, so they're dialed back and just said we don't have any opinion at all on whether or not abortion should be legalized and some of the other issues that I was trying to discuss with it. So the bias has been, or perceived bias has been all over. I often argue, by the way, I think the bias in these systems tends to be, it's not that humans are in there tweaking it because there's a trillion parameters that have to be tweaked, so you don't have to do that trivially. Of course, it's just training examples, but there's not that much training data, label data that goes into it. So bias is really reflecting more about the, whether or not you perceive that there's bias largely in there. Okay, so I always ask people, do you think that the internet is biased? And the majority of people, so I should do that here. How many people think the internet is biased? Yes or no? Okay, hands for yes. Okay, now a tougher question. Is it biased to be too liberal or is it biased to be too conservative? Liberal? Liberal. There you go, liberal. And is it too conservative? No, and you can, okay. My argument is it's neither, because it is a reflection. It is arguably a reasonable sample, large sample of human insight. Okay, and it is, you could argue that, well, there's some bias in the creation, self-selection, sort of people contribute to the internet, whatever that means in this day and age. Might have a different view than those who don't. So there's a self-selection bias, but largely I think bias is a discussion more around the content that goes into it than the algorithm. And then the whole issue with misinformation. Misinformation initially was, you may recall that, and it's still the case with ChatGPT, because it's such a big model, is trained not with the data that was available as of the latest quote yesterday, but rather data that's typically a year old. So it used to be that if you asked it, when did the war in Ukraine start, it would tell you 2014 because it had been trained before the March 2022, whatever the most recent war started. That, by the way, I should mention, has changed in a sense, and that's pretty amazing. Effectively, what it's doing now is very similar to what Google is doing with AI overviews. That is, if you ask it something, like I haven't done this, but if I asked it the S&P 500 go up or down yesterday, it will give you the answer. That's not its training data, but it realizes it knows what it doesn't know, so to speak. And what I can do is search, and it uses Bing because it's heavily invested, funded by Microsoft, goes out and does a search, and then uses, on the search, to be fairly traditional text summarization tools that have been around for a decade to generate a result. So it has gone from giving misinformation, because it didn't have that information, to giving, and basically to saying, well, I don't know, to actually then sort of filling in the gaps with a search data. So now let me go back and talk about something I haven't talked about before in these talks, and that is generative AI and higher education. So I want to talk a little bit about, and certainly the people in this room know a lot more than I do about this, but I think it's an interesting discussion of how we integrate AI into educational curriculum. And as I said, I serve as a Ph.D. advisor, can we generate new results. So this is a high-level view that summarizes sort of my thinking about how we integrate AI into educational curriculum. So, interesting enough, when I first gave this talk, which was in this summer 2023, so it was, of course, ChatGPT had just come online in that school year, and the New York Public Schools, for example, began to use ChatGPT on their networks. Okay, and I think some other schools felt that they weren't sure how to deal with it. I mean, they caught everybody by surprise, certainly. Tried to limit its use as well. But I think that quickly, to my knowledge, I think it was not that long after the New York school system, of course, recognized that there's no way, that made no sense to do that. And so now, of course, everybody is faced with, how do we integrate this into our curriculum? So I guess my view is sort of simply stated here, which, is certainly not a novel view, is that there's clearly a delicate balance here. On one hand, we need to continue to teach students to do critical writing, critical thinking, problem solving, because they can't do anything without knowing that. But the other hand, we have to recognize that they are going to do that in the context of advanced AI tools moving forward. So the simple statement, which in reality is much more difficult to realize perhaps, is we need to be able to do both. And how do we make things challenging so that we, again, preserve sort of both ends of that balance. So, say that I have some help with ChatGPT here, but I'm proud to say that these are largely my own sort of conversations. So what are some of the advantages for integrating AI? And now I'm not really talking necessarily about higher education, I'm really talking about education all the way from preschool to adult education. Students may benefit from personalized learning. I mean, we've known that for a while, and now we can optimally tailor it to their educational needs. Okay, and I think this is when somebody, one of the first talks I gave, I was an interview I gave on this, they asked me sort of, what are the really important advances that AI will have? And I said, I think in preschool and early school education. Because why? Because AI systems are always there, they're available 24/7, they have infinite patience to be able to do anything, and they adapt. So I will argue that, and I think people agree, AI systems can stimulate curiosity in independent learning. I think there's no doubt about that, if they're used correctly. I think interacting with these systems just makes learning more fun. And anytime you make learning more fun and more engaging, I think you make it more efficient and more effective. Students can obviously need to prepare for future careers by learning how to collaborate with AI systems. So, you know, in some sense, I mean, one of the important things pre-AI that we taught kids, hopefully we taught students, is how to work in a team. Okay, because when you go in the workplace, your success is often the success that you bring and your colleagues bring to a team effort that you know, optimizes across the range of insight and input from humans. And simply stated, we're changing that model now. Now we're going to add a AI system to these humans, but we're going to still do the same thing. We're going to seek an optimal solution to a challenging problem, but we're going to rely on AI to fill in and expand the, if you like, the insight that even a team of humans bring. So that's the way that we're going to be using AI in the future in many professions. Okay, it's not that AI is going to replace those jobs, it's going to be integrated into it. That's a corollary of that. Then the question is, well, what's going to happen to the job market moving forward? That's not full talk. And the real question is, in past technological innovations, what we've seen in global history, what we've seen is that, yeah, there are jobs replaced by this new technology, whether it's robotics or automation, whatever, but new jobs become available to global technology. Well, certainly in the case of the internet was obviously a net gain in jobs because it was an underlying platform that lifted up everything. I think what it remains to be seen is sort of how AI will play that role. And finally, I'm not a teacher, but I suspect many people here are. Good news for you guys is that it can help preparing plans, curriculum, and so forth. And even that mundane class they used to assign to TAs called grading homework assignment quizzes. You now have access to a TA that isn't any more reliable than I was when I was a TA. So, but not to shortchange things, there's a lot of challenges. So the first one is, what I was saying before, we need to ensure that students do not become too dependent on AI. So you can't just do your homework assignment, submit it to ChatGPT and turn in an essay on critical race theory. That doesn't benefit anybody. So they have to continue these essential life skills, as I said, problem solving, critical thinking. The next point is an interesting point. It's something that ChatGPT told me, and I modified it a little bit. Human teachers recognize the emotional and psychological needs of students, and my argument is that AI systems arguably do not. I mean, one question I've been asked before is, do you think can an AI system start to do that? Can it start to recognize emotional and psychological needs of students? I'm of the opinion that absolutely it can. I'm a belief that if all of the sensory observations that are available are made available to humans, that is, you can understand how the student responded, you can analyze body language, whatever it is that you like, and their perhaps history of interaction with students, teaching, and so forth. I don't understand why it is that an AI system can't become much more efficient at that, but I think that is maybe a minority opinion, which is why I say something I don't 100% agree with that current systems are. Well, I guess I agree because I use the word current. We need, and this is an important three that we saw, most notably the internet, and this to me is very important. We we need to make sure that these benefits are available across the board, most notably disadvantaged school districts and special needs students. And that still continues to be an issue with, as we know, access to high-speed internet in the United States. I mean, we are closing that gap, but compared to like when the internet became available, unfortunately, it's another one of the, it's an unfortunate sense it's a technology that does so many things that we need it to do, but unfortunately, it also broadens the gap between the well-to-do and the less well-to-do, and that's unfortunate, but I think there are ways of being aware of that and addressing it moving forward. I think point 4 is kind of silly in my view, but again, I'm relying on ChatGPT's head here, that students need to recognize that AI systems, like humans, are not perfect. And one of the things that frustrates me about the evaluation of AI systems is, in my biased view, we hold AI systems to a higher standard than we hold humans. So when AI makes a mistake, we all go crazy, and it ends up on the front page of the New York Times. I'm talking about a mistake that impacts national security or something like that. I'm talking about a mistake that it doesn't know, something about basic about U.S. process, which was in the news a year ago. We don't seem to ever question the fact that and compare it, as we ought to be doing, to human response. So I think it's quite clear that we recognize that students pretty much learn, and the parents have told them that, listen, humans, teachers, they have opinions, they have biases. In some sense, in some settings, these can be viewed as suboptimal, to use a technical term, but I would suggest that AI systems are no different. And this is something that came up in sort of a local school board district where the parents were concerned about private and personal data in AI tools. My statement to them is if you ever use Google or Chrome, your personal information is a whole lot more exposed than it is with ChatGPT, so get over it. And that's the least of your problems. OpenAI's got plenty of ways to make money without selling the data. Okay, so now on to this topic here of can ChatGPT serve as a thesis advisor? So just some background. So I made the statement there at the top, a critical first step in getting a PhD is picking a viable thesis topic. Actually, before that, sort of deciding what you want to do, where you want to go, who your thesis advisor, and so on. But I have seen so many, and not so many, but I've seen thesis topics fail, theses fail, not because the student wasn't capable, but because they picked a topic that either was undoable or was trivially doable and nobody really cares. The key is to find something that matters and to do a great job solving that problem, is what it said. So what I basically said was, I started thanking you since we're talking about machine learning and deep learning as a subset of it. I asked ChatGPT to propose potential topics for a PhD thesis in machine learning with an emphasis on deep learning. And it came back with 10 topics. I'm going to actually show them to you, not go through them in detail. And basically, here's the first one, explainable deep learning methods. Deep learning, again, involves this massive neural network where an input is put in, it is transformed through a series of what are called layers. These layers, each have nodes, which are nominally represent neurons in a brain. They're connected by what are called links, and by computer scientists are called synapses, even very loosely, by brain scientists. And it effectively learns weights on each of these links that will optimize across a very large transformation of that input. That input is the query, and that output is being text image, whatever. Okay, so a big issue there is explainability. And that's an issue throughout machine learning and AI is, if you're in finance, on my end, certainly if you're in healthcare, if you provide a recommendation, a financial recommendation, whatever it is, or a medical diagnosis, the next question is going to be, well, tell me more, how do you know that? Well, these methods are great at providing an output, but they're not very great at explaining. In fact, very, very few people, I often say there's less than 10,000 people on this planet who really understand what's going on under the covers in ChatGPT. And that, I think, is a concern. And so if you don't understand it, it's real hard to explain. By the way, it's real tough to regulate if that's your concern, because regulating black boxes is to be a very challenging technical discipline. So basically what it did is it came back with that and gave me some key areas to explore. and challenges and so forth. But let me just real quick run through, again, this is localized to this particular area. Adversarial robustness, I'll go down. I heard you had a very nice talk this morning, I heard on adversarial issues and intrusion and so forth with AI. Meta learning of efficient deep learning method. Meta learner is something that has multiple learners underneath that and learns how to weight them in an appropriate setting to get an optimal outcome. Efficient deep, number 4, the efficient deep learning for edge computing. That's basically these models we know, literally, I'll talk about that in a moment, taking good power plants to generate enough electricity to train them. The question will be moving down into smartphones and such and so forth, computing on the edge, if you like. Deep learning for healthcare applications, of course, is an established area, and it brings some more. And again, just to complete, so let me go through the others. Generative models for synthetic data generation. So one of the big problems with these models, of course, is they just continue to need more and more data. In fact, it's an interesting observation, is the training of these models, we might actually be reaching an asymptote in how much these models can learn. This happens in traditional machine learning because we're reaching an asymptote, maybe, on how much useful data is available on the internet to train it. Of course, unfortunately, generating massive amounts of internet data every day, and significant fraction of which are probably not worth useful for training. But nevertheless, there's ideas around can you generate synthetic data, which means, by the way, you need to have a forward model, that is a model that is not unlike the model that you're using to train to actually generate this data in a way that you fill in the gaps in sensible ways so that when the learner learns that, it no longer needs to hallucinate and fill in the gaps because those gaps are filled. However, those gaps were filled with a different model which could be hallucinating as well. So there's a whole challenge there and sort of a circular argument as to how this would work. Self-supervising learning for large-scale data. It's very, very difficult to get lots of labeled data that says this is an image of a cat, this is an image of a dog, and so like that. That's an example of a dog. Many images, like in expressions of natural language, it can be more complicated. You certainly have the internet, which is and textual representations that you can learn against. But the point is, we need to be able to do a better job of actually using unlabeled data, which ChatGPT is very efficient to generate better learning techniques. Reinforcement learning is very key part of deep learning. In fact, OpenAI is just recently involved in they started using that. There's a company that Google bought a few years ago called DeepMind, which is in London. In fact, it was one of their scientists who developed a protocol AlphaFold, which recognizes reinforcement learning with substance stuff that is, in fact, was recognized in the Nobel Prize for chemistry this year because it does predictions of protein structure and it is indispensable to scientists in that area in understanding proteins. So what is reinforcement learning? The best example of it, I think, is computer chess. Now, at IBM, in fact, when I was at IBM, we had a system called Deep Blue. This was back in 1997, that beat Eric Kasparov. And real quickly, the way it worked is it just had a very efficient way of, if the game was at a certain state, of searching 13 flies, 13 half moves ahead, which is enough to make it, 3,000 plus grandmaster, and optimally sort of generating this massive treatment and pruning this tree back to get the optimal next move. So it was basically a very computational efficient way of doing a very, very deep search. Back to reinforcement learning, what DeepMind has done in the last several years is they have a completely different, they call it AlphaGo, that's also to beat the best players in Go, the very complex order management, more complex than chess, but it also beat the best, it's by far and away the best chess game. And by the way, it knows nothing, all it knows is what chess pieces can do, how they move. It knows nothing about historical games or anything, and what did it do? It just played itself millions of times. So it would go through playing a game of chess, look at the output, and it would look at that output and either give it a reward or a penalty and say this is either a favorable outcome or a not favorable outcome, and then back through the algorithm again to adjust it to learn that piece of insight. And it didn't need to have any labeled data because it was just playing itself and was learning how to generate these moves. And it is easily, by far and That's done by computers for decades now. But this is an interesting insight, and this is now being factored into many other, and I'll show you an application here at the end. Deep learning for autonomous systems, again, self-driving cars, so this is that, and that's an example. So I'm sorry, the last one's kind of funny. I guess it was, it's deep learning for natural language understanding. Well, we already have that's called ChatGPT, effectively, and even sources of that. So my only point here is that this can do some pretty amazing stuff in terms of generating ideas. Now, then the question becomes, somebody might ask, well, how long will it be before generative AI can actually produce a PhD thesis? I mean, I heard Dr. Singh mentioned somebody published 100 papers or whatever in 3 months. What I guess my statement is that I firmly believe we're not there now, at least not in disciplines I'm familiar with, where it could generate a PhD. I mean, what is quite clear is it can probably generate novel content. Okay, again, that novel content doesn't necessarily mean that it's correct. It's just different. Okay, same thing with the course references in the legal brief. They were novel, but they were different, but they were wrong. Okay, and I'll come to this in a moment. The real question starts to become, when are we going to have generative AI generate new science, new physics, and we're the threshold of that. So. Oh, sorry. So one other, just to close out this discussion, this is interesting because I was talking about this morning. I was speaking to the woman who did that. It's very interesting discussion I had with her. But please, so I said, well, topic number 2 seemed kind of relevant. Here. Please elaborate on the potential machine learning PhD topic, adversarial robustness, and deep learning networks. So how can we protect these complex methods from somebody coming in, intruding, and changing the training data, maybe somehow changing guardrails around and so forth to do things that for which are unlawful outcomes. So it lists a set of potential contributions. I'm not an expert in this area, but as indicated for people who are. But once again, it's very, very skilled at bounding sort of an interesting topic space. So now sort of the last discussion that I'll just touch on here is, can generative AI, and I really sort of keep using generative AI. This is really a discussion really more broadly about AI and generating sort of results. So again, back to DeepMind again, the method that's in the Nobel Prize chemistry. So sorting algorithms have been around for 50 years. I mean, anybody who's ever taken an American methods course in computer science has written a sort algorithm, and it's used, every millisecond, if you like, on the internet and so on. So, believe it or not, in Nature Fundamental publication, and new results, this is actually a result from last June, there was a paper called Faster Sorting Algorithms discovered using deep reinforcement learning. So how did they do this? Again, it's a little bit like when you have a hammer, it looks like a nail. Okay, well, these guys had a very efficient way of casting something as a single player game. I haven't mentioned chess yet. What they did was they first took the sorting process and recast it as a single player game. And then, so now they've got something that looks like a nail and they've got the hammer. So what they did was they used their capability called that was designed to optimizing this performance just by playing itself many times. Where the objective is not to win a chess or to win a go, but rather to produce a fast sorting algorithm. So you can specify that as an objective, and again, I mentioned briefly, you have a reward or penalty, and you can come back and produce an optimal outcome that, in details of which I'm not quite clear how they were then able to encode that basically in C++ code. So this is actually now part of the library of Google. And this, even though humans have been doing this problem for as long as there have been computers, this is the fastest sort algorithm that's available right now, and it was found by AI. Which to me is a mind-blowing observation. It's one thing to find maybe a really obscure discipline where nobody's actually looked at. I mean, people look at sort for decades. The other thing so this is the other result that I found kind of interesting, that I've often wondered about. It feeds into, system about sort of climate science. So how do we generate weather forecasts now? Well, we write down a very large, complicated set of partial differential equations that explain the relevant physics. And we then approximate these with all kinds of different techniques. My PhD thesis was approximating something to do with neutron physics, but approximating this equation on a computer and then solving it. Now, there are several challenges there. Number one is the physics is generally understood, but the physics may not be fully encapsulated in the partial differential equations that are solved. There are parameters in it that have to be adjusted, and then there are numerical errors, and that's a small part of it associated with approximating these equations. The other way to do it, which is the way that this publication is done here, and these are people from Google, not from DeepMind, but Google Research in California. What they did was they just started looking at bitmaps of regular images of preceding data. What do you mean? You need pressure, you need wind velocity, and you need precipitation. And without understanding any physics at all, just took a deep learning network and had it learn to transform, and talk about transforming through this large network, the input, which in this case were bitmaps of the underlying observable data, and then producing an output, which was precipitation in I guess the next 12 hours, I recall. And guess what? Without understanding any of the physics, it does a better job than the models that are based solely on the physics. Now, again, this comes back to interpretability. Is, well, wait a minute, it can, how do I, other than observing it, or how do I know what's going on with covers? And the simple answer is you don't. But what is interesting is you can start to look at these neural networks and sort of pull pieces of insight out of them. And what they've been able to do here is actually go in and understand sort of deficiencies in the physical model based on what the neural network, data-driven model, if you like, has been able to determine. So I think this is an example of how we are, maybe tiptoeing into doing physics. I don't think right now ChatGPT is capable of providing new physics that surround us, but it's certainly capable of solving the same problem, just coming from a much more data-driven perspective. Now, how does this impact sort of climate modeling? Climate modeling, again, is the same basic idea. You have very complex sets of partial differential equations that, of course, not predicting weather in the next 12 months, but it's defining over decades. And a key part of the scientific and political discussion is how do we optimize, these slightly technical terms, how do we optimize an outcome based on the inputs that we have at our disposal? That is, what policy decisions can we make about carbon emissions and so forth that are going to be more efficient at producing an optimal climate solution moving decades out. Now, we already do that because we have these models, and these models, you can adjust these models based on some actions that are taken. But in some sense, what I'm suggesting here is that deep learning and AI can provide a more formal framework in which to embody these objectives, just like Cindy's did, it doesn't just work out. So that is, I think, the last slide, and I've said this a couple of times. I mean, as Dr. Singh was saying, you are operating at the absolute leading edge of technology. I mean, I think if you look back over the history of physics or chemistry or anything else, I mean, we are in an environment now that we may not have seen. Maybe we saw in physics when the first particle accelerators started coming online. We're creating new elements almost every year. I mean, we're at a time now where, just this week, as I said, we both Nobel Prizes have been given. And by the way, I should mention that the physics prize was somewhat controversial. In fact, I mean, quite clearly, Jeffrey Hinton should have gotten would have gotten an award in computer science, since we don't get a Nobel Prize in computer science. And some physicists felt that this wasn't real physics. And in ways, I mean, there are ways that deep learning is being used in experimental physics, whether or not the extent to which that is starting to really impact physics. But there's no doubt that this is the leading edge, and I think we're all should view ourselves as being quite fortunate to be able to participate at any level, from being sort of a consumer who relies on technology to somebody who uses it to do everyday tasks, somebody who drives sort of fundamental research in this area moving forward. So let me just finish up with one other sort of just a bunch of things that I tend to think a lot about and talk a lot about, but I didn't talk about here. The number one is the whole issue about its facilitating generation, dissemination of false information. So, of course, it's come up with the fact that I don't know, we've had elections in this country less than 4 weeks away, but there have been a number of elections throughout the world. I think this was a slide that I used like a year ago. It hasn't changed that much. I think what has happened in general, we have no shortage of misinformation, but it's generated the old-fashioned way. It's generated by people lying, and lying in such a way that this data is immediately promoted through social media. So what I've often said in response to this, we have a potential perfect storm that we've created social media, which is the most efficient platform that humans have ever generated to spread misinformation. Because instead of having a handful of content creators like we had 5 decades ago, we have a couple of billion on the planet who can all create content and you go out there. Mark Twain famously said, a lie goes around the world twice while the truth is still getting its shoes on. And the bizarre thing is he said that 100 years before we even knew what social media was. So then on top of it, when you take this platform that's very efficient at distributing misinformation, now we give it a platform we call generative AI, very efficient at generating misinformation. So this is a perfect storm, but as I say, I don't think that has been fortunately quite realized in the election data we've seen so far. There's a whole range of intellectual property issues that have to do with the fact that ChatGPT is trained against the same internet search index data that Google uses, but it also, of course, supplements it with licensed data. For example, data that is behind the New York Times paywall is actually in the training data that ChatGPT and OpenAI uses. By the way, they pay the license to the New York Times to use that data, so it's not like they're evading licensing issues. But the problem is that the reason the New York Times is suing them is not because they're using the data, it's because they are now putting out responses that are arguably quite similar to New York Times content. So even though they ingest out a lot of other data, by the time they trained it, they came out with phrases that New York Times published as well. So there's a whole ton of issues here that I often talk about the fact that you need to think about this, and we're trying to, in a way, mimic the way human inventors work. But at the same time, we need to hold AI responsible for the same safeguards and IP provisions that apply to humans. I mentioned the issue 3 about knowledge-based jobs. Another interesting discussion is what would be the effect on the economy as a result of generative AI. And one way to think simply about the economy is if you think of GDP as sort of a product of 2 factors, the number of people who work in the workforce times the GDP per worker. Okay, just into that simple model. GDP per worker, of course, reflects not only the efficiency of the worker, but the whole efficiency of the infrastructure for which they do this job. Okay, now what is 100% clear is efficiency. That term will increase. Humans will become much more efficient, and we've already seen that, of course. Other technological advances, they will become much more efficient. And the real question is, well, what's going to happen first? The number of workers who participate. And that's a lot of discussion that I think if you look over a range of economists, you'll get a range of observations. I don't think there's any sort of unified opinion on that. Point for the whole issue about AI needs to be regulated. As you know, OpenAI and other people almost completely put Congress to regulate that. I think we saw what happened with Zuckerberg and Facebook. Facebook got out of control and Congress started beating on Zuckerberg, and Zuckerberg was like, Congress will please regulate me, because when things go south, I want to be able to point the regulators rather than my own internal development staff. So I think we're seeing the same thing in AI, and just as an observation, you may know that like in the last week or 2, the governor of California, who had signed a previous bill into law which greatly which limited the ability to do and increase the penalties for disseminating misinformation generated by AI on the internet. That was passed, but then a much broader bill, which was an attempt to sort of identify which AI needed to be more regulated. It had to do with, among other things, how long it took to train, how much it cost to train it. That was rejected because from a large pushback from the tech community that felt that this was overstepping. So it's an interesting discussion. On one hand, the tech community, having seen kind of what happened with with social media and issues there are saying that they want to be regulated, but then when you try to put regulation in place, it's problematic. So right now, there's no federal regulation in the U.S. There is the European Union did in fact pass regulation that's really more based on classifying applications of AI into 4 domains and then putting different regulatory requirements in each domain. AI models require massive amounts of electricity. How much electricity? Well, 10 times more than Google search to do the ChatGPT case. Right now, I think I saw a number from Goldman Sachs, 1 to 2%. AI training is using 1 to 2% of energy production and electricity production in the U.S. and Europe. That's estimated to go to 3 to 4%. And what's one example that came out right there with Dr. Sing's introduction is you may have read that first of all, 3 Mile Island had an accident in March of 1979, just in the height of my Ph.D. defense in nuclear engineering 2 months before then. So that was an interesting personal observation. So that plant had a serious accident, shut down literally since then, although it still exists. Microsoft just entered into an agreement with a provider to resurrect that plant by, I think, by the end of 2027, that will generate, something approaching 1,000 megawatts of electric. So, and Microsoft is dedicated completely to training AI, training and hosting AI models. So that gives you a sense of the power consumption. And the final issue of AI destroying humanity. This is a discussion that's been around for decades, and it's a very cyclical discussion. And when AI starts becoming really sort of, ingrained in our everyday discussion, like ChatGPT, you tend to see more discussion of this. My personal view is that I think these systems are safe right now. I don't think there's a near-term threat, but I think longer term, clearly, we need to be able to, regulation will become an issue, I think, trying to enforce certain ethical guidelines without vaccines, and also just trying to put guardrails on it. Being not sure the technical session, to try to ensure that these systems remain safe. So let me stop there. I apologize for going slightly over, and we've got time for questions on anything I said.
Thank you very much. Any questions, please?
Thank you very much. What is your take on whether the progress in generative AI will lead to eventually a artificial superintelligence or general intelligence, and what are the possible consequences of that?
So the question basically is, the holy grail in this business is not generative AI, it's general AI. So what is generalized AI? That's AI that can basically reason and provide insight across a very broad range of topics, essentially the entire set of topics that are of interest to humans and perhaps beyond that, super intelligence. It is largely due today, ChatGPT, although it's an amazing advance, easily the greatest advance in AI ever, has not reached that. And there's an ongoing discussion about whether or not these just basic training techniques are sufficient to learn really simple, sort of intuitive concepts that humans learn every day. And which I think is sort of one way of recognizing whether or not, even though sort of I'm not answering the question yet, I know the answer, which is one way of sort of instantiating generative AI. Somebody that I know who's ran a Boston project with we were both at IBM, a system called Boston PhD best players in Jeopardy in the world in 2011. He's moved on to a company called Elemental Cognition. And what he's trying to do is achieve that goal by bringing in a different set that sort of falls on more traditional AI that was more rules-based and therefore limited, but a much more sophisticated way to try to modulate this, to try to get it beyond where we are, where we're still gated by training data. Because what do we know? Humans are probably better maybe at filling in the blanks where there's missing training data than AI algorithms are. So we need to have a more efficient way of doing that. I suggested a couple of technical ways of doing that. And your question is, if we get to general AI, will it destroy humanity? I guess the simple answer is there's a better chance. It has a better chance of doing so than we have today. But again, the question is, if it's true it's truly generalized, how do we even know where to put guardrails in? And how do we probe the system? It's difficult now. How do we probe the system? How do we know that ChatGPT performs ethically? Ask a lot of questions, and that way we'll learn the answers to that just modify moving forward. If we move into the regime that you're talking about, all of the complications that we have today are increased by order of magnitude in terms of understanding interpretability, the regulation, and so forth. So I guess the one answer is no, you cannot rule out the fact that these systems can, because by their very nature, they're now generalizable, that indeed can generalize in the domains that humans are fully equipped to deal with. Please.
Do you expect more evolution, more foundation models, or more focused fine-tuned add-on models?
Well, it's interesting. I mean, you consider ChatGPT to be foundational? Yeah, that's fair enough. I mean, I'm just trying to sort of establish what foundational means in this context. I think ChatGPT largely caught experts completely by surprise as to how amazingly effective. I'm not sure you had thought of the performance on college entrance exams. Nobody would have ever believed that ChatGPT could do 1410 SAT running, SAT verbal now. So yeah, that's foundational. When I see Sam Altman talk about how he's going to spend $100 billion now, $1 billion, I mean, it's some astronomical amount of money. He tends to be focused more on, building larger data centers and so forth. So I would suggest, I think, maybe your comments, maybe that's more incremental, other than the fact that Sam Altman probably has some ideas as to how he can greatly expand foundational if you give him, 1,000 times or more computing power. I think to the first question, I think he found the next. A future foundational objective is generalized AI. Okay, and I don't see that we're anywhere close to that now. These systems are still fallible. I would say that one difference is we used to know exactly where they fail, because we used to understand how these systems work, before we had this massive learning network. Now the problem is we don't know how we really don't know how they work. We don't know what causes hallucination in great detail. So I think we need to do a lot of things that maybe you would agree are not foundational, but yet are still important. So I think the great foundational move is to continue to enhance along the path that we're on. The transition is to continue to enhance on the trajectory we're on now. At the same time, continue to view what are we going to do when we have 10,000 million times more compute power, a million times more electricity, and all of it there, in order to train these models. I'm not sure that even Sam Altman can tell you if all of a sudden tomorrow he had an infinite amount of compute resources. I'm not sure he could tell you exactly what he would do with it. So that's a good question. And again,
Two more questions. We're in a tight schedule. Go ahead.
please.
So I'm curious about the change track, the huge consumption of electricity for the AI. So basically, the background in computer science, if you ask the people about the future, the possible and effective solution to meet this kind of electricity.
Oh, you mean, so how are we going to generate the electricity? That is, remains to be seen. I mean, the short-term answer is apparently we resurrect nuclear power plants that have been closed for 40 years. The longer answer is all of the above. I don't know. I think we have perhaps finally found an example in human progression that clearly outstrips, as you're suggesting, our ability to generate energy. We've never had it in this country. We've argued a lot about how we generate that electricity and the overall efficiency from the climate and so forth. But we've never really been concerned about having enough. We've had big concerns about having enough of it that's reasonably priced, and big concerns about generating enough of it that doesn't destroy the planet. But we've never had a discussion about when people come and say, well, I need 1,000 times more, because that's not going to happen. So that's a completely different discipline. And I have no informed answer other than the fact that it will become a challenge, unlike we've ever seen before, because we've not encountered something that would suck this much electricity out of our infrastructure right now to do something that everybody agrees is a useful thing to do, but we just don't have the electricity to do it at the scale that Sam Altman and others dream about.
Can you comment on what the developments with quantum computing and AI can impact the intersection of these two?
Yeah, that's a good example. I mean, I don't think about quantum computing very much anymore. And again, I'll expose my ignorance on quantum computing, but what I'm not clear on is if quantum computing, if there are instantiations of quantum computing that are optimally designed to do more efficient computing than we have now. So just thinking off the top of my head, a very crude example is GPUs that are produced by NVIDIA. GPUs have been around. By the way, the G-schemes are graphical. Okay, these seem to use to accelerate graphic algorithms in the 1990s. Okay, and it turns out that they have an architecture modified to make them remarkably efficient at the operations that are required to train and apply a neural network. Okay, so that's an example of at least a technology that has evolved hand in hand with AI. We would not have AI without GPUs and their extension. I assume, but again, because I'm not an expert, that there might be instantiations of quantum computing that again would lead to new optimizations that are able, that again would enable new foundational applications of AI. That's certainly from my perspective, that remains to be verified.
All right, thank you very much. This was excellent. And we would love to